Hi, this is Dr. Kunka Bheemalingappa, faculty of CSE. I heartily welcome you. In this video, we are going to learn how to convert epsilon NFA to NFA. Coming to the contents, these are the contents that what we are going to cover in today's session. First, what is this epsilon NFA? Then NFA. And how do you make a conversion from epsilon NFA to NFA? So what is this epsilon NFA is this? The transition function of epsilon NFA can be stated as follows. Delta star of Q epsilon is epsilon closure of epsilon. Delta star of Q A can be stated as follows. Epsilon closure of union of R belongs to epsilon closure of Q delta of R A. This is the transition function of epsilon NFA. In a similar fashion, the transition function for NFA can be stated as follows. Delta star of Q on epsilon is Q itself. Note down the basic difference between the transition function on epsilon. That is, in case of epsilon NFA, delta star of Q epsilon is epsilon closure of epsilon closure of Q. This is Q. Let me write it clearly. Yeah. Epsilon closure of Q. Whereas the transition function on epsilon, for epsilon in NFA is this delta star of Q, epsilon is Q itself. This is just Q in case of NFA, whereas in epsilon NFA, it is epsilon closure of Q. In a similar fashion, delta star of Q YA for Y belongs to sigma star and A belongs to sigma can be defined as follows. That is, delta star of Q YA is equals to union of R belongs to delta star of Q Y delta of R A. This is a transition function of NFA. I hope you have clearly understood what is a transition function for epsilon NFA as well as for NFA. Now, by taking an example, we will see how to convert epsilon NFA to NFA. Suppose you have the following epsilon NFA. This is your start state. This is your start state. Let me name this state as 1. This is on input A. You have a transition to state 2. On input epsilon, from state you have transition to state 3. Also you have a transition from state 3 to the state 2 on epsilon, and there is a transition from state 2 itself on input B, and also you have a transition from state 2 on input B to the state 4, and you have a transition from state 3 to the state 4 on input A, and from state 4 to the state 3 on input A. This is the epsilon NFA. Yes, the name implies the basic difference between this just NFA and epsilon NFA is that epsilon NFA will have transitions on epsilon. In just NFA, you don't have transitions on epsilon. So how to convert epsilon NFA to NFA? That is what we are going to learn in today's session. Let me draw the transition table of this. Let me use a different color. Can I get other colors? This is transition diagram of this epsilon NFA. You are known what are the input symbols that what you have? A, B, and then epsilon. On these symbols you have transitions. You are known what are the states that you have in the diagram. That is 1, 2, 3, and then 4. So these are the states that what we have here. And let me take this state 3 as a final state. Your known final states are represented with double circle. Let me treat this the state 4 as also a final state. So you have two final states in the given epsilon NFA. They are 3 and 4. So this is your start state. Let me change the color. This is your start state. 3 and our final states. So in the transition table, except our final states are denoted with this circles like this. So from 1 on A, where you can go to the state 2. So you are going to get the entry here as that is a 2. From 1 on epsilon, you can go to the state 3. So 1 on epsilon, here you are going to get the entry as 3. And then 2 on A, you don't have any transition. 2 on B, that is 2 itself. 2 as well as that is 4. From 2 on input B, you can go to, from 2 on input B, you can go to state 2 and 4. So here you are going to get the entry as 2, 4. Only outgoing transitions you have to take into consideration. And then From 3, on A you can go to state 4. From 3 on epsilon you can go to state 2. So under epsilon column I have to write that is a 2. And state 3 doesn't have transitions on input symbol B. Next, coming to state 4. 4 on A you can go to state 3. 4 on A you can go to state 3. And it doesn't have transitions on input symbol B as well as on epsilon. So this is the transition table which corresponds to this epsilon NFA. Epsilon NFA. You are known, right, how many transitions are there, right, in the diagram. That is 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Yeah. How many entries you got? 1, 2, 3, 4, 5, 6, 7. That is cross check. So this is a table which corresponds to this epsilon NFA. Now we are going to look at how actually you are going to make a conversion from epsilon NFA to NFA. So in the conversion process, you are supposed to find epsilon closure for each and every state that whatever you have in the epsilon NFA. You are known that you have 4 states, 1, 2, 3, 4. 1, 2, 3, 4. So first you have to find epsilon closure of 1. Epsilon closure of 1. So epsilon closure of 1 is what? Epsilon closure. Just I am going to write CLOS, which stands for, that is closure. Yeah. Epsilon closure of 1. In a similar fashion, I have to find epsilon closure of 2, epsilon closure of 3, and epsilon closure of 4. So these are the 4 different states that what we have. In the diagram, if you carefully watch, I am going to highlight the transitions on epsilon, only on epsilon. So where do you have transitions on epsilon? That is here and also here. You have 2 transitions on epsilon, right? Yeah. So epsilon closure of 1 in the sense, first what do you mean by epsilon closure of S? Rule 1, what it says is epsilon closure of S in the sense S is added to epsilon closure of S. So as per that, here S is 1. So epsilon closure of 1 in the sense, first you are going to get that is a 1. From 1, if you can reach any other state only on epsilon transition, then that state should be added. So from 1 you can reach state 3. So 3 can be added. And also you need to continue. From 3 if you can reach any other state only on epsilon, then that state should also be added. So you are known from 3 you can also go to state 2. So in the order I am writing, so you can also add this 2. So that is, what do you mean by that is epsilon closure of 1? You look at the diagram. From 1, including that 1, what are the other states that can be reachable only on epsilon transition? From 1 you can reach 2, that is 3. You cannot, only on epsilon you have reached this 3. From 3 only on epsilon you can also reach, that is 2. Therefore this 3 and 2 they are going to get added. So that is epsilon closure of 1. In a similar fashion you have to find the epsilon closure of other states. Can you tell me what is the epsilon closure of 2? As per rule, first 2 can be added, and from 2 if any other states can be reached only on epsilon, then those states must be added. But from 2 you don't have outgoing transitions, or say okay, leaving transitions labeled with 2. Therefore epsilon closure of this 2 is 2 itself. And then coming to this epsilon closure of 3, according to the rule 1, that is first 3 is added. 3 is added. Epsilon closure of S in the sense, rule 1 what it says is S is added to epsilon closure of S. Here S is 3, therefore epsilon closure of 3 is 3. Next, from 3, can you reach any other state? Only on epsilon. From 3, I can go to state 2. Therefore, this 2 must be added here. So, if you want to write in the order, you can write 2, 3, or say that is 3. So, epsilon closure of 3 is 2, 3, or say 3, 2. In the order, if you tell, it becomes 2, 3. Yeah. Next, epsilon closure of 4. Epsilon closure of 4 in the sense what? First 4 is added, and then from 4, do you have transitions, outgoing transitions labeled with epsilon? No. Therefore, epsilon closure of this 4 is 4 itself. Epsilon closure of 4 is, okay, 4 itself. Yeah. Now, you have seen at that formula, epsilon closure of QA is what? Epsilon closure of union of R belongs to epsilon closure of Q delta of RA. That is the transition function of epsilon NFA, right? So, whenever you want to find this delta of, here you are known the states are 1, 2, 3, 4. Suppose if you want to find the delta of 1A, what you are supposed to do is this. First, you have to take the epsilon closure of the state. Here the state is 1, and then you have to apply this transition function, that is delta, and then once again you have to apply this epsilon closure, right? You are known for state you are finding this. Epsilon closure of 1, just now we have found, that is okay, 1, 2, 3. First you are going to get 1, 2, 3. Let me use a different color if you want. Epsilon closure of 1 is 1, 2, 3. Here for what state you are finding, you are known that is 1, right? So, epsilon closure of 1 is 1, 2, 3. So, for input symbol A you wanted to find. Here the input symbol is what? A. So, you have to take from this epsilon NFA table, you have to take the union of 1A, 2A and 3A. So, 1A is 2, 2A is okay blank, 3A is 4. So, 1, 2, 3 on A. 1, 2, 3 on A. You have to take the union of this. So, on taking the union of this, what you are going to get? That is 2, 4. This is the, that is what the formula it says. Union of delta of RA. Yeah. And then once again you have to apply, in the outside you have that, okay, epsilon closure. See, let me show. See, first you have to apply the epsilon closure of a state, that is here Q is 1. I have found the epsilon closure of 1, and then I have applied this transition function. Your known epsilon closure of 1 is okay, 1, 2, 3. For 1, 2, 3, your known input symbol is what? A. Yeah, 1, 2, 3 on A, you have to take the union. That part I have completed. So, this part I have completed, and then I have to apply this epsilon closure. So, for the result that whatever you have got after applying this transition function, you have to apply the epsilon closure. So, I think you are clear. So, for this, I have to apply this epsilon closure, that is for 2, 4. And your known epsilon closure of 2 is 2 itself, and epsilon closure of 4 is just okay, 4 itself. So, what you are going to get then? If you take the union of all this, right, just you are going to get, that is 2, 4 itself. So, delta of 1A is 2, 4. That is the transition function of NFA. That's what you are going to get. If you want, you can, let me write it here. You are known the basic difference between, for what state you want to, yeah, you are known what states you have. 1, 2, 3, 4, right? 1, 2, 3, 4. You are known what input symbols you have. You have two input symbols, A and B. You have only two input symbols. This is transition table of NFA, right? NFA. NFA. That color is not. Okay, I can change it. NFA. Yeah. So 1 on A, what you have got, that is 2, 4. 2, 4. 1 on A you have got, that is 2, 4. So whenever you want to find delta of 1B, what you are supposed to do? Already you are known this epsilon closure of this, okay, state 1, right? This one. So that is, you are known, that is 1, 2, 3 itself. But this time the input symbol is different. That is, in the previous case you had A, but this time you have the input symbol as B. So you have to take the what? 1B union 2B union 3B. So you are known what is 1 on B, 1, 2, 3 on B, that is blank, 2, 4 blank. If you are going to take the union of right all this, what you are going to get? That is okay, 2, 4 itself. 2, 4 itself. And then you have to apply the epsilon closure of this, okay, 2, 4. So epsilon closure of 2 is 2, you are known. Epsilon closure of 4 is 4. So what you are going to get finally? That is 2, 4 itself you are getting. So delta of 1B is what? Delta of 1B is 2, 4. Therefore you are going to get the entry here as what? 2, 4. I think you are clear. Yeah. In a similar fashion, you have to find right with respect to the other states. Shall I erase this part? Where is the eraser? Yeah, this is the eraser. So for A, it is completed. Yeah. So in a similar fashion, you have to find 2A and 2B. That is okay, delta of 2A. What is delta of 2A? What you are supposed to do? First you have to find the epsilon closure of 2. What is the epsilon closure of 2? You are known epsilon closure of 2 is 2 itself. And then 2 on A. What you have the entry? 2 on A is, that is blank, nothing. So if your epsilon closure of nothing is, okay, nothing itself. So you are going to get the entry 2A as what? That is okay, blank itself. I think you are clear. Next you have to find delta of what? 2B. 2B. Already I have found this epsilon closure of 2. So epsilon closure of 2, you are known that it is 3 parts you have, right? Yeah. If you want, I can extend this. You have two input symbols. Yeah. This is for A part and this is for okay, B part. This time you want to find delta of 2B. So epsilon closure of 2, you are known that is 2. 2 on B is what? From the table. 2 on B, that is okay, 2, 4. You are going to get 2, 4. And then you have to take the epsilon closure of this 2, 4. You are known epsilon closure of 2 is 2, epsilon closure of 4 is 4. Therefore, you are going to get that is 2, 4 itself. Therefore, delta of 2B is what? 2 and 4. Delta of 2B is what? 2 and 4. I think you followed this. In a similar fashion, you have to find delta of 3A. So, I need to change this okay, states. That is, and then these things they are going to get changed. Let me erase that. Next. So this time yeah, you want to find delta for 3A. delta of 3a. That is this entry you have to find. If you want, you can keep the okay brackets for this. You have more than one state, no? Yeah. First, you have to find epsilon closure of state 3. What is the epsilon closure of state 3? Epsilon closure of state 3 is 3, 2 or 2, 3. That is okay in the order. Let me write that is 2, 3. And then you have to find the union of 3a and then 2a. That is 2a union 3a from the table. This is 2, this is 3. So 2, 3 on a, that is blank, and 4. If you are going to take the union of these two, you are going to get that is 4. Is that clear? 4 you are going to get on a. And then you have to find epsilon closure of 4. Your known epsilon closure of 4 is 4 itself. Therefore, what you are going to get, delta of 3a is 4 itself. Delta of 3a is 4 itself. In a similar fashion, you have to find delta of 3b. First, you have to find epsilon closure of 3. That is epsilon, delta, epsilon, right? So, already you are known epsilon of this, okay, 3. That is same thing, 2, 3 itself. No need to rewrite, okay? If you want, you can take 2, 3. So, this time you have to take 2, 3 union of 2, 3 on B. You are known this 2, 3. So, 2 on B is 2, 4. 3 on B is blank. So, if you take the union of, okay, these two things, what you are going to get? 2, 4. You are going to get that is 2, 4. And then once again you have to apply this, okay, epsilon closure. Epsilon closure. So epsilon closure of 2 is 2. Epsilon closure of 4 is 4. You have to take the union of them. So you are going to get what? That is 2, 4 itself. I think you are clear. So 3 on B, what you are going to get? 2, 4. 2, 4. So you have been left with just one more state. So with respect to 3, it is over. Now we find with respect to state 4. So let me erase this part. Here you are going to get the changes. Yeah. Delta of 4a, and then you have to find delta of 4b. First, let us look at delta of 4a. First, you have to find epsilon closure of 4. You are known epsilon closure of 4 is just 4. And what is your input symbol? A. So you have to, from this table, transition table of epsilon NFA, you have to find what is this 4a. What is 4a? 3. Right? Therefore, here you are going to get it 3. And then you have to find epsilon closure of 3. Epsilon closure of 3 is what? 2, 3. 2, 3. 3, 2 in the sense that is 2, 3 in the order. So, 4a, what you are going to get? 2, 3. This is what you are going to get. In a similar fashion, you have to find with respect to the input symbol B for state 4, delta of 4b. So, you are known epsilon, delta, epsilon. So, epsilon of 4 is 4 you are known already. We have found. And then this time input symbol is going to be differ. So, 4b. What is 4b? There is a blank. So, epsilon closure of blank or say nothing is nothing itself. That is empty. So, 4 on B, what you are going to get? That is a blank. 4 on B, you are going to get it as blank. So, you have got the transition table of this NFA from the transition table of epsilon NFA. You have got transition table of NFA. What is the basic difference between these two in terms of this transition table? In epsilon NFA, you have the column for transitions on epsilon. Here you don't have column for transitions on epsilon. That is a basic difference. Epsilon NFA will have transitions on epsilon. NFA will not have transitions on epsilon. You have done your job. Now, I have done my job. If you want to get a transition diagram from this table, and if you want to check some strings, you can check out. It is up to you. Let me erase this part. Yeah. Let me draw this transition. You are known in the epsilon NFA transition diagram. Your start state is what? 1. So here the start state is going to be the same. And you are known what are the final states in this epsilon NFA? 3 and 4. So same states will be the final states in NFA. And one more important thing you have to remember. From start state, you are known what is the start state in epsilon NFA, that is 1. If you can reach any one final state only on epsilon transitions, then you have to treat that start state as final state. So here you are known the start state is 1. From 1 I can reach on epsilon the state 3, and you are known that state 3 is a final state. Therefore, I have to make this start state as final state. That is an important thing you have to remember. I repeat, from the start state, if you can reach any one final state only on epsilon transitions, then you have to treat that start state as final state in NFA. So this is what this. Now let me draw this transition diagram. You are known what are the states that you have. 1, 2, 3, 4. So from 1 on input A, you can go to state 2. Also from 1 on input A, you can go to state 2. You are known. Sorry, that is state 4. Already have written for 2. This is 4. Let me write it clearly. This is 4. Yeah. 1 on B, you can go to same states, 2 as well as 4. That is B. Length has become. Yeah. From 2, you don't have transition on A. On B, you can go to state 2 and 4. That is from 2 on B, you can go to 2 itself, as well as you can go to state 4. Yeah. And then 3 on input A, you can go to state 4. I have not yet written the state 3. Let me take this. From 3 on input A, you can go to state 4. From 3 on input B, you can go to state 2. From 3 on input B, you can go to state 2, as well as you can go to state 4. 3 on B, you can go to 2 and 4. And then from 4 on input A, from 4 on input A, you can go to state 2, as well as you can go to state 3. This is your state 3 on input A. On input A. And you are known what are the final states here. Let me take a different color. This is a different color. You are known what are the final states. 1, 3, 4. So I'm going to represent this 1, 3, 4 are final states. If you take some string that is accepted by this epsilon NFA, it must also be accepted by this NFA. Take for example, on reading AB, you can go to, in epsilon NFA, AB can be read as follows. From state 1 on A, you can go to state 2. From state 2 on input symbol B, you can go to state 4. This 4 is a final state. So AB is going to get accepted. So how this AB is going to get accepted in a NFA here is this. This is start state A and then B. From 2 you can go to that is state 4. This is the path A, B. So that is going to get accepted. In a similar fashion, if I take this path epsilon A, so A is going to get accepted by this epsilon NFA. So how it is going to get processed in the sense, so from 1 on A you can go to state 4. So you are there in final state, therefore this A must be accepted. So A is going to be accepted by both epsilon NFA as well as NFA. If you take some string like say, if you take this path epsilon, epsilon, B, if you concatenate at all these symbols, the string is going to be what? That is B. So the B is going to get accepted by this epsilon NFA. Then that B must also be accepted by this NFA. How it is going to get accepted? Yes, see, from 1 on B, you have the transition to the state 4 itself. You are known that 4 is a final state. I think you have clearly understood. So whatever the string that is accepted by this epsilon NFA is going to get accepted by this NFA. The basic difference between these two is that in epsilon NFA you have transitions on epsilon, whereas in NFA you don't have transitions on epsilon. Conclusion, they both accept the same language. The basic difference is that in epsilon NFA you will have transitions on epsilon, but in NFA you don't have transitions on epsilon. Thank you for watching the video. Wish you a good day.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.